There we go. Okay. Sorry, it took me a while to find it. Okay, and if you see me doing this, it's my bifocals. I'm not trying to look down on my nose on anybody. So welcome to everybody to our monthly lunch with the League. My name is Melanie Smith-Guillaume. And just in case you are not aware, the League of Women Voters is a nonpartisan organization. We do not support parties or candidates, but we do study issues, and we support or oppose them after we've studied them and come to consensus on them. Don't forget that we have a user's guide out, and it's online also, as well as in a paper copy. We are recording, and you can see this online and other League meeting, Lunch with the Leagues online on our website. Our next meeting will be July 12th, and Paula Sowers will be our speaker. She's going to be talking about minority businesses, so that should be very interesting. Also, I'd like to request everybody to mute themselves and put your questions in the chat, please. Our format is a half-an-hour presentation and a half-hour questions, but sometimes that is a little flexible according to depending on our speaker. And our speaker today is Dr. Alan Hamlet. He is an associate professor in civil and environmental engineering and earth sciences at the University of Notre Dame. He's a specialist in computer modeling of climate, hydrologic systems, water resource systems, and ecosystems. And he has been involved extensively in modeling studies in North America and the Midwest and the Great Lakes region. So he's right up our alley, our geographical alley here. And I'd like to welcome him and turn the microphone all over to him. Alan?
Thanks very much. Sorry, I'm turning my phone off here. So I'll share screen here, but thanks very much for the invitation first off, and please feel free to contact me via email afterwards if we don't get to your question or need other information. Let's see. Okay, you should see the title page. Is everyone seeing that okay?
Mm-hmm.
Yeah, all right, great. So my topic today is fairly indicative of the kind of work that I do. So in this case, we're really relating an important problem, nutrient pollution, to climate and land use and other aspects of human behavior. And finally, then at the end of the talk, we'll examine some of the things that we can do to try to minimize the impacts of these kinds of problems. So to begin with, sorry, I'm hiding controls there. So why do we care about nutrients to begin with? Well, I think that one of the main reasons that we care about them is hypoxia, or low oxygen conditions in the coastal ocean has reached a global ecological crisis level. These are some of the hot spots for hypoxia. So I'll show you some pictures of what this looks like in just a moment. But in the US, you can see that many of the coastal areas, both on the west and the east coast, are strongly impacted. So, and one of the largest and most intense depleted oxygen zones is in the Gulf of Mexico. So down here on the map, also the Chesapeake Bay up here. But you can see many other places, particularly in Europe, we see a lot of areas that are affected as well. So hypoxia is caused by algal blooms. And those algal blooms are impacted by the nutrients that are received from rivers and other sources that enter the coastal ocean. There's an algal bloom in the coastal ocean. And then as that algae respirates at night and decomposes at deeper levels, it depletes the oxygen to the point where things cannot live in those so-called dead zones. So again, I'll show you what those look like in just a moment. All right, so I just want to highlight that this is not a problem just for the US, but it is a global problem. Sorry, trying to get my... All right, so I mentioned the Chesapeake Bay. This is a forecast that you can access here down at the link down here if you're interested later. This is a forecast for today, and they estimate what the hypoxia levels are in the bay. These red areas are very low oxygen. So a threshold of 2 milligrams per liter. So that would be kind of orange to red colors here. So these areas all up in here are very low oxygen that could cause death of marine organisms. All right, so you can see it's a large area. Baltimore is up here, Washington is here, and it's not an accident that downstream of those cities that we see these large impacts. So a little closer to home, this is the very large hypoxic zone that is present in the Gulf of Mexico. These are pictures. This is a picture of the extent of it in 2023. And then this is a time series down here. So from 1985 to 2023. And so these are very large areas that are affected. So for example, in 2017, which I'll show you in just a moment, we had nearly 9,000 square miles of hypoxic conditions all the way to the bottom that killed marine life in this huge area. And this is primarily because of the Mississippi River coming into the Gulf here and bringing with it agricultural runoff that contains nutrients, particularly nitrogen, which is the limiting nutrient in most marine systems. But this is a really gigantic area. So for 2017, just to put this in perspective, the dead zone was approximately the size of New Hampshire. So nothing living in this huge area all the way down to the bottom. So not everyone is aware of this, but it is really a global ecological crisis. These are not small impacts, but just kind of astounding. So what does this look like on the ground? It looks like this. I mean, this is just sort of a swath of the coastal ocean right up against the land. So this is just dead fish as far as the eye can see. And the damage is not only to fish, but all organisms that live on the bottom too. So the bottom, if you look at it in these places, is just a wasteland. There's nothing living, that uses oxygen. So again, these are really kind of frightening ecological impacts. So the nutrients feed the algae that ultimately cause the hypoxia. And so where do the nutrients come from? They come primarily in the Gulf of Mexico from farmland, and specifically in the Midwest. Now you can see these different watersheds that ultimately feed to the Mississippi. So here's Indiana, the Wabash and the Kankakee both ultimately drain to the Mississippi. There's a lot of farmland in both of those watersheds. So Indiana is a very significant contributor to the nutrients that ultimately wind up in the lower Mississippi basin and enter the Gulf, and along with other areas shown in this figure. So the Mississippi, of course, is a very large drainage. So this is a significant portion of the agricultural area in the United States. All right, so marine environments are very strongly affected by nitrogen, but freshwater environments are also significantly affected. And usually the limiting nutrient in freshwater systems is phosphorus. And one of the poster children for this is Lake Erie. This is a satellite image. You can see these very extensive algal blooms that are just this bright fluorescent green color. And if you look at this close up, it looks like this, just like pea soup, that kind of consistency. This can cause very serious health problems. Both hypoxia is certainly one issue in freshwater systems as well. But it is also, it tends to produce blue-green algae, which emits neurotoxins. So this can cause health scares. So for example, if a dog were to go out to a lake that had blue-green algae at this level and drink the water, the dog would die. So there's a risk to pets and even humans. In August of 2014, Toledo, Ohio's water system was shut down for 3 days due to toxins from blue-green algae. So this is what the algae level looked like, and this is the intake of water for Toledo. Now, it may not sound like much to shut down a water supply for 3 days, but it actually is a huge deal. So 500,000 people were without water for 3 days, and that takes a lot of response to, bring in bottled water and those kinds of things to support people during that time. So water managers really do not like a shutdown of any duration for a water supply system. And of course, as you bring a system like this back up online, there's a lot of testing that has to go on too. So it can take more than just the impact days to bring the system fully back to operating condition. All right, so this was a wake-up call that the things in Lake Erie had really been pushed over the edge. Now, climate change, on top of this this source of nutrient that is coming from farmland in the Midwest, climate change for the Midwest is also believed to exacerbate this, and I will show some results from our modeling studies at the end of the talk. But I think it's helpful for us to understand some of the mechanisms by which climate change will ultimately impact nutrient pollution in the Midwest. So some of you may have seen these kinds of pictures before, but what I'm showing here in the top row are percent changes in precipitation for the water year from October to September. And then in the bottom row are changes in temperature in degrees C. So 6 degrees C, which is sort of approximately how much warming we would expect for the highest scenarios in the 2080s. That's about 10 degrees Fahrenheit, just to convert those for you. So the climate change projections for our region suggest that we will see very strong increases on the order of 25 to 30% increase in precipitation in the fall, winter, and spring, accompanied by strong warming, on the order of 10 degrees Fahrenheit on average across different seasons. So this has very profound impacts for the hydrologic response of rivers. This figure shows the change in the fraction of November to March precipitation that falls as snow. So on the left side is the historical snow to precip ratio. And so red areas here are areas that don't have very much snow. Blue areas have a lot of snow. So as we move into the future to the 2080s, you can see that these red areas that don't have much snow are steadily moving north and becoming more intense. So what's happening is we're losing snow in the wintertime and snow cover. And I think the last few winters have been kind of a dry run for these kinds of impacts. We haven't seen a lot of snow in the early part of the winter, and what snow does come quickly melts. All right, so with warming, we see a conversion from from snow to rain. And as a result, we tend to see more surface runoff occurring because of that. On top of that, we also see in that time of year an increase in precipitation overall. So not only is it being converted to rain, but there's also more precipitation. All right, so what happens then to seasonal rivers? This is a paper that some of you may want to look at the technical details later, so I just give our reference down here. But what we've done is look at 20 watersheds and look at their hydrologic response for historical conditions, and then look at them for climate change in the 2080s. I'm going to show you results for all of them, but I'll highlight site number 19, which is the bottom of the Wabash River and the Maumee River. This drains ultimately to Lake Erie, and this one is number 10 is responsible for a lot of the nutrient pollution that's entering Lake Erie. All right, so what's happening in the wintertime? We're getting more precipitation. And we're getting more precipitation as rain. And so what happens is the surface runoff in the middle of the winter, in the fall, winter, and spring tends to increase dramatically. So instead of getting snow on the ground, we're having rain falling on watersheds. All right, so if we look at number 10, the Maumee, you see this strong increase in runoff in the winter months, much larger than the base case historical condition, which is shown in blue in each of these. So what happens when you warm a watershed and increase the precipitation in the cool season is you get a lot more runoff in the cool season. And the reason that this is important is this is exactly the time when our farmland is typically fallow. And so we have bare soil out there that's laden with nutrients and pesticides and other things. And as we increase this runoff, we expect then that the surface runoff is going to increase, carrying with it these nutrients and other contaminants. So this shows watersheds that are like the Maumee and the Wabash. You can see that the response is rather similar. Both of them show these big increases in runoff during the winter time. Some of the more northern basins, they also show strong increases in the wintertime, but the peak flows may or may not be higher in those cases. So some watersheds show increasing flood risk, others show fairly minimal flood risk. Okay, so we have crisis level nutrient pollution entering the Gulf of Mexico and places like Erie and many other areas globally. So what can we do about this? One of the more promising approaches is to use cover crops in the wintertime to attempt to store the nutrients that are present on these fallow fields temporarily. And then in the spring, the cover crop is killed and allowed to release the nutrients back to the soil so that the main crop, like corn or soybeans, whatever it is, can then grow using those nutrients. So in this study, we used computer models to explore how cover crops performed both under historical conditions and then also for climate change conditions, because we wanted to see how they would do. And our hypothesis was that cover crops might actually be really effective under climate change because the cover crop is really growing at the time of year when the runoff is increasing, as I just showed you. And those increases then could be potentially reduced significantly by the cover crop because it's at the right time of year that the cover crop is growing. All right, so what does a cover crop look like? One of the typical cover crops that's planted in winter is cereal ryegrass, which looks like this in the springtime. This grass is quite durable and can handle our harsh winters. So it grows, it's planted in the fall, It grows in the fall until things get too cold, then it becomes dormant for a while. And then as the temperatures warm up in the spring, it grows some more and ultimately reaches, some sort of biomass like this. So all of this biomass here contains nutrients that have been taken up by the cover crop and are now not available to run off into the streams when we have storms. So that's the strategy. So to explore how well this works, we implemented a hydrologic model called SWOT, which also is capable of simulating the growth of the cover crop and also the growth of the traditional cash crop. So typically corn and soybean in our part of the world. And we looked at two small watersheds, the Kirkpatrick Ditch watershed and the Chateau Ditch watershed. These are almost entirely agricultural areas that drain to these ditches. And you can see it's kind of a roughly 50-50 mix between soybean and corn. All right, so the assumption here is that we're planting cover crops in the fall in the case of implementing them, or if we don't have cover crops, then there's just corn and soybeans in the normal growing season. And so then what we do is simulate using these computer models how much nutrient comes out the bottom of these watersheds that ultimately would contribute, in this case, to the Gulf of Mexico. All right, so the first experiment that we did is we looked at the effects of cover crops alone. So what's shown in these graphs here along the x-axis is just the average for the different months from October to September, the traditional water year. And these are then nitrate losses. So this is nitrogen that ultimately is coming from the farmland. And if we have no cover crops, that's shown as the red trace here. And if we convert all of the farmland and plant cover crops, then the nutrient loss is shown in blue. All right, so what we see is a nice reduction in the nutrient loss in the winter and spring. And then when the traditional cover crop comes on, there's not too much change. It's about like it was without the cover crop. So we don't see any reduction in nutrient availability, really. What we see, though, is a nice reduction in the loss of that nutrient to the ditches and ultimately to the rivers that flow to the Mississippi and the Gulf of Mexico. All right, so this is for nitrogen. In the case of soluble reactive phosphorus, or SRP, we see a similar reduction. And you'll notice there's this interesting peak here. So phosphorus seems to release a little bit of more nitrogen, excuse me, a little bit more phosphorus in the growing season. And this is an interesting effect that, in a sense, there's a lot of phosphorus around, and when the decomposing cover crop happens, we get this peak here in the early spring and early summer around this time of the growing season. All right, so not perfect, but we see, especially for marine environment, this is a nice reduction at the time of year when we really want to reduce the nutrients that are going to the Gulf of Mexico. These figures up here show that, there is a strong relationship between the annual precipitation, in other words, how wet the particular year is, and the nitrate loss that comes from those farm fields. So in other words, the wetter the conditions are, the more nitrogen loss we see. And we see a similar pattern for phosphorus, although it's not as strong as it is for the nitrogen. This is important because for climate change, we expect to see more precipitation on an annual basis. And so we expect to see sort of systematic increases from climate change alone. All right, so this is the effect of cover crops. And this has been supported by a number of studies. My co-authors, Dr. Jennifer Tank and Todd Royer at Indiana University, both have been measuring these nutrient levels for a long time, and they see very clearly these reductions in nutrient loss that go with these cover crop implementations. All right, so this is the effect of cover crops alone. We're just looking at the historical record, no change in climate, just what happens if we plant cover crops in the wintertime. This figure shows what happens when we have climate change alone. So in this case, we don't plant cover crops, but the climate changes and continues until the 2080s. So this is a snapshot of the 2080s. And you'll see there's kind of a range here. This is the range of the climate change simulations, the average of which is shown in this dark brown line. And then we also see this is the historical condition in the dotted line. So what do we see? Not too surprisingly, as we expected, we see this increase in runoff in the wintertime for climate change. And as a result, we see more entrainment of nutrients in the runoff, and we see larger losses that occur under climate change. And we see that for both nitrate and for SRP. So if we do nothing, this problem, which is already at a crisis level, will become significantly worse. So this is very unfortunate situation where climate change is likely to make our watersheds much more potent in terms of releasing nutrients to the environment, with implications for places like the Gulf of Mexico and many others worldwide. All right, so a key question then is, what happens if we have climate change, these impacts, but we implement winter cover crops with 100% coverage? And that looks like this. These are somewhat complicated figures. All right, so what's shown here is the climate change without cover crops, that's shown in brown. And then with green, in the green colors, this is the effects with 100% cover crop coverage.
Mm-hmm.
So we can see that even though we have much higher nutrient losses with climate change alone, when we implement the cover crop at 100% coverage, we actually get back to something that looks rather like what the historical record with 100% cover crop looks like. A good way to show this is down here on these bar charts. So what I've done here is created a baseline. This is the historical condition with no cover crops. And then I've looked at 3 different scenarios: historic conditions with 100% cover crops, climate change alone over here, and climate change with 100% coverage of cover crops. So you can see, if we compare the baseline, this one, to the climate change one, we're seeing a strong increase of about 20% of nitrogen pollution. But if we implement cover crops for this climate change condition, we can almost get back to the same level as the historical condition with cover crops. So what this shows is that cover crops are working better under climate change than they do under historical conditions. This is one of the very few situations where that is true. Most of the time, climate change is a disaster across the board. In this case, we have a little bit of a silver lining in that key management strategy that we have that tends to reduce cover crops in the historical condition works better under climate change. So even though we see a 20% increase due to climate alone, when we implement cover crops, we can get back to about minus 30%, comparable to what happens under the historical record. So this is This is quite nice. And we see this also for phosphorus, although the increases are not as severe, only 6% in this case. Again, we see we can, with 100% coverage, we can get back to historical levels. So why is this happening? What's going on is that the cover crop, which is just a crop at one level, under warmer and wetter conditions, it is putting on more biomass in the wintertime, and it's storing more nutrients during the wintertime, and that is reducing the amount of nutrients that's coming out of these watersheds more under climate change because the biomass of the ryegrass is more. So this is an encouraging result, and certainly one that we thought might happen, but it's really surprising how well this works. So we're currently looking at some larger watersheds to see if this is reproduced in those conditions and how significant it is. But again, these initial studies on these small watersheds are very encouraging. So a few conclusions I just want to leave you with. First off, nutrient pollution is a global problem, not just in the U.S. And many areas in the U.S. are affected, not just the Gulf of Mexico, Chesapeake Bay, and Lake Erie. But in the Midwest, climate change has a very important effect on what is happening to runoff and therefore nutrient effects. And nutrient runoff from the Midwest and farmland in the Midwest in particular has been a major factor in increasing the nutrient pollution and hypoxia in the Gulf of Mexico and Lake Erie. Climate change, however, will also bring important opportunities to adapt, and cover crops can reduce nutrient pollution now and even more in the future. So these are a very sustainable kind of reduction in nutrients from cover crops. Now, we're assuming here that we have 100% application over farmland, and of course, that's not really achievable in real life, but that shows us sort of the best case scenario. But nonetheless, we expect to see significant reductions if you can implement this over a large scale. Now, that said, although the performance of cover crops is very encouraging and becomes more effective under climate change, by themselves, cover crops are likely not enough to meet the kind of management objectives that groups that are trying to control these impacts are trying to achieve. As a result, other measures such as reducing fertilizer application, dynamically controlling tile drains, restoring wetlands, removing nutrients from treated wastewater, and so forth, well, those will all likely be needed to help bring nutrient loads to a sustainable level. So I'll stop there, and we can take questions then.
Okay. We have questions in the chat here. I'm looking for them. Alan, can you see the questions? I can read them to you.
I can see them. I'll read them out.
Okay.
Here. Let's see. Let's see. Why are these toxins referred to as nutrients? It's not that the toxins are referred to as nutrients. It's that the nutrients cause certain kinds of algal blooms that release the toxins. So under very eutrophic conditions, when we have a lot of nutrients, particularly phosphorus, then blue-green algae can form more easily and create a toxic algae bloom. So the nutrients essentially cause the algae to grow that releases the toxins. Does that make sense? All right, so Yes, someone else answered this in the chat too. All right, so lawn fertilizing can be detrimental, as well as insecticides or herbicides. So this is a great point that these impacts also occur at smaller scales. So if you have a small lake and everybody around the lake has a lawn and everybody in those lawns fertilizes them, then we could have eutrophic conditions in that lake that would create harmful algal blooms, or even if they're not blue-green algae, just so intense that the use of the lake might be really unattractive for most people.
Yeah.
So this can happen in rivers too.
Yeah.
You know, if people have lawns that ultimately drain either directly or through a short channel structure into the river, if you're fertilizing your lawn, a lot of phosphorus can be released, and that ultimately can wind up in the Great Lakes or the Gulf of Mexico. Let's see.
Mm.
Let's see. One person commented, I can see the change in precipitation here locally based anecdotally on what it was like in the 90s as a kid, and recently, and that my solar panels have produced more energy each year so far. Yeah, that's a good point. You know, we do see, I think we have seen some drying in the late summer also, which is consistent with what we see in terms of late summer precipitation going down in the projections. But if you look at historically at the precipitation in Indiana, it has been rising steadily through time. So there's a strong trend that's consistent, at least, with the climate change projections. All right, let's see. Are farmers receptive to addition of cover crops, and do cover crops generate income? Both great questions. Some farmers are very receptive to the use of cover crops and have actually been contributing to the science by documenting what they do and what happens. So I think most farmers, though, have been reluctant to plant cover crops unless there's a source of revenue from that. So sometimes we will try to approach farmers to help us with the science by providing a small stipend for just the labor of planting the cover crop and so forth. Some farmers are trying to find a way to make use of the cover crop. So if you plant a different kind of cover crop, like perhaps wheat or something like that, then you might be able to actually grow that as a second crop. So there's some efforts to approach things in that way. So if you look at the historical statistics, in any given year in Indiana, it's about 10% of the cropped area has cover crops on it. And that doesn't sound very good, but actually Indiana is a national leader in terms of the amount of cover crops that we have. So it has been a hard sell, I think, to get farmers to participate, but I think there is interest, and over time that may change. Again, this is not something that we can ignore, and the farmers are very concerned that if they don't do something themselves, that the government via the EPA or others may step in and try to regulate these sort of things. So they're very interested in solving the problem themselves. So again, cover crops can potentially generate income, but that's largely people trying things right now to see how well that works.
Right.
Let's see, cover crops make a lot of sense. 2 questions. In your opinion, should your suggestion of cover crop be advanced at the local level, state level, or national level? That's a great question. I don't think I have a strong preference for for any one of them. My suspicion is, in order to be successful, we will have to have efforts at all of those political scales. I would say now it's kind of at the level of individual soil and water conservation districts. So for example, we have efforts by the St. Joseph Soil and Water Conservation District. And they have farmers there that have been trying cover crops for a long time. And so there's a meeting on June 24th, I think. No, June 27th, called Meet Your Farmer. And so they're going to have talks, I hope, from farmers who are innovating, and cover crops is one of the strategies. Cover crops have other benefits for farmers too. They improve the fertility of the soil, particularly if you combine them with no-till practices. So they also absorb carbon, which is beneficial in terms of reducing climate change. So there are some other advantages as well. So I would say it's been mostly at the local to state level, maybe, that has been the primary. But I think the EPA is certainly one of the key federal actors who may become more involved in trying to encourage farmers to do a better job of reducing nutrient pollution. Right now the numbers vary from place to place, but on the order of 50% of the nitrogen that is applied to fields winds up in our waterways, which is a pretty terrible ratio. Let's see.
There's a second question there.
Yep, sorry. Second question, since COVID, have we seen concerted efforts against science and experts? I have not, and have you encountered disinformation, misinformation regarding implementing cover crops? I personally have not seen that. I think people have been encouraged that it works well. And I think actually the response has mostly been of trying to gather information, by interested parties. Certainly farmers are interested. Does this work? And so their colleagues who have tried it, I think they're very interested to hear from them. I think it works a lot better if farmers share their experience rather than scientists. I think farmers are much more interested in listening to other farmers than me about what works on their fields. So I think there's a lot of interest in generating these so-called peer-to-peer interactions where farmers talk to farmers. That helps, I think, also, kind of reduces the us versus them kind of things that can happen in these kinds of discussions. Let's see. Does conversion of farmland to solar panels or data centers help by taking land out of ag, or does it increase runoff during flood events and offset any gains? Both very good questions. One thing that's certainly true is you're not going to be fertilizing the land where you have solar panels. There's no need to do that. So that would be a helpful thing. Indeed, the solar panels can increase the amount of runoff that occurs. It depends on what is underneath them. So I think climate change will increase the runoff no matter what we do to the land, and we can make it worse by having impervious surfaces or other things like that. But I think, many of the solar farms, you have the panel, and the water will drip off onto the ground below. And it tends to make the amount of runoff larger because the amount of area that's exposed to the water dripping off the panel is a smaller area of land. So there's less infiltration. All right, so I think both of those, it's not clear to me which is going to be more, but I think my suspicion is that the reduction due to not having any fertilization every year will dominate in that case. And we probably would have less, at least nitrogen coming off. Now, phosphorus, at least in many areas of the Midwest, is not added. There's just a lot of phosphorus around, and that might increase. So we might see differences between nitrogen and phosphorus in that regard too. This is certainly an issue because a lot of farmland is being converted to utility scale solar farms, and we need to understand this. Has the research community presented this information to Indiana legislators that are attempting to reduce our wetlands? Certainly, some legislators are aware of this. And I think they are aware of it in part because of groups like the Soil and Water Conservation Districts that publicize what happens and are certainly talking to policymakers about these kinds of things. Wetlands are an alternative strategy. It's another way of trying to reduce nutrient pollution. And indeed, Indiana has recently implemented laws that are very unfriendly to restoration of wetlands. So certainly that's a step in the wrong direction. I think there is certainly an effort to influence the policy in a better direction, but that doesn't mean that the policymakers are going to take action in the way that we hope. So this might be an area where the League of Women Voters could make a difference. Let's see. The change for farmers to use no-till methods has been slow, but has occurred. Yes, that's correct, I think. Are you optimistic about political will to advance cover crops and other methods to reduce nitrate and phosphorus runoff? Yes, I'm optimistic, and I think the key to it is to solve the economic problems. I think if the farmers can make money, it doesn't necessarily have to be a lot of money, but something, they're going to be far more willing to take this on. So right now, a lot of the studies that have been done in collaboration with scientists, there's some grant money that helps fund the farmers' participation. But the key question is, well, when that money is, when the study is over and that money dries up, then do the farmers stop doing it? If so, that's not a lot of help. So how can we, so for example, if we could find a cover crop that had some economic value that was sufficient to pay for itself, I think the farmers would be far more interested and willing to go ahead with that kind of idea and that kind of business model than just doing it for free and trying to having it effectively reduce their income. Let's see. So I would say political will, it has been difficult to get large scale reductions in nutrients, and this is true also of cities. So cities produce nutrient pollution as well, and you can retrofit a water treatment plant to remove nitrogen from the wastewater, but that is expensive, and there has to be initiatives, and essentially taxes have to pay for that. So if we have a situation where the local government or state government has been unfriendly to environmental policy, I would say there is less likelihood of success in allocating money to those kinds of projects. So this is always a problem with environmental problems. How do you generate the political will to invest in the technologies that you need, even if they exist? Policymakers may be unwilling to take those kinds of actions. I think there's another question about acres of solar panels, which I think we've addressed already. Let's see. So soil and water conservation districts, please explain what those are and how are they set up? So these are usually at the county level. So in the example I gave, St. Joseph County, other studies that I've been involved in, Vanderburgh County in Michigan is another one. So they tend to be at the sub-state level and at the county level. And the purpose of these organizations is to preserve and conserve soil and water, and that includes improving water quality. So St. Joseph County, I know, has in the past been involved in green infrastructure projects also, such as rain gardens. The Unitarian Church, First Unitarian, where some of us on the call are, we installed wetlands via a grant from the St. Joseph County. So there's a lot of, that's a good political scale to try to address things, I think, is at the county level, and to bring in the soil and water conservation districts as a partner, I think is a good way to generate consensus, and also to, create continuity that will ultimately keep things going. That's a role that the conservation districts can play much more easily than can a group of individuals. So you can read up on the soil and water conservation districts. I'm not sure when this structure was formed. That would be interesting to find that out. So
We've got two more questions here, and that just is going to conform about to the time we have left. So that's good.
That's good. Let's see. If cover crops reduce runoff, does that equate with less frequent use of applications of nutrients by farmers? Not necessarily at all. It's kind of distinct, right? The cover crop takes up the nutrients. It's sort of a biological storage and release mechanism. The cover crop takes up the nutrients in the winter. The storms come and they create runoff, but because the cover crop has stored the nutrients, they're not available to run off. Then they kill the cover crop in the spring. It decomposes and releases the nutrients, and then those nutrients can be reused by the corn and soybean crop. Mm-hmm. So, but how much nutrients are put on the ground in the springtime by the farmer, that's pretty much independent of the cover crop. So remember in that figure I showed you where the phosphorus sort of spiked in the early summer? That was because the cover crop was releasing phosphorus, and there was also just natural phosphorus from the environment being released at the same time. So that creates that little spike. And a similar thing can happen with nitrate, potentially. If you're applying nitrate to the ground and then you have the decomposing cover crop, it can create a little spike in nutrient loss at that time in the early summer. But the kinds of alternatives that are being explored, I think, are, can we reduce the amount of nitrogen that the farmers are applying to the ground to reduce the amount of runoff laden nutrients that comes? So if I think it's fairly clear, if you over apply the fertilizer, it's going to wind up in the water, and that's not what you want. It can happen too, just via bad luck. You apply the You apply the fertilizer and then there's a big rainstorm the day after. That can be just a disaster, and all of it just washes into the ditch and is not available for the plants and creates a water quality problem. Same thing if the ground is frozen. That can prevent it from infiltrating. And then when the next rainstorm comes, it can just wind up in the ditch. So they're separate, but certainly both connected to the water quality issue. There was some suggested reading regarding some apparently failed cover crop legislation. I don't have much comment on that. So other questions that didn't get addressed?
Anybody else want a quick last question? I see no hands.
Wait a minute.
Yeah,
Cynthia.
I think there was
maybe
one
but
question.
it really is a more general question, and that is, this also relates, your field of expertise also relates, doesn't it, to regenerative farming, which is a different term. But if you could explain how regenerative farming would fit into cover crops.
Tell me, regenerative farming, explain that to me. I don't know that term.
Where the crops are cycled in such a way that no additional fertilizer or augmentation is necessary.
Great. I think actually it would work just fine and would create even further reductions, because the cover crop does not diminish the amount of nutrients that are available for the main crop. It basically stores the nutrients that are on the fallow farmland and then releases them again at the time when they're needed for the main crop. So I think you could do both cover crop and the regenerative farming idea. And I think that's what people are thinking, you know, in terms of how much, like if we could have the amount of fertilizer, I'm just making a number up, but if we have the number of amount of fertilizer that was applied in the spring and could still, you know, achieve reasonable yields from the main crop, then putting the cover crop in place would implement further reductions, I would say. But I think they would be compatible. But that's a very interesting question. That's something that could be explored with the kinds of studies I just showed you.
We have a new message. Alan, thank you so much for sharing this very important information. And we found several areas that the League of Women Voters could help with. I think that's true. And you pointed out one or two. But, you know, we have water studies, we have solid waste studies, we have, I don't know if we have anything for soil. But Pam?
Yeah, there was one more question I think Mary Kay asked. There is an increase of acres of solar panels, and how does this affect the solution?
I think we addressed it in the earlier topic, but just to reiterate, you know, there wouldn't be any fertilizer application on the solar panel. And that's where a lot of the source of nitrogen is coming from. So that would be helped. The runoff that occurs would likely increase because the available soil for infiltration is reduced when you have panels. And so that might increase the phosphorus loading in particular. Even though, you know, we're not putting any phosphorus on the ground, either in the farm or the solar panel, by increasing the runoff, you might actually increase the phosphorus.
So you need cover. You need ground cover between the solar panels.
Yeah,
I've actually seen
that might help, and they do
Mhm.
that, you know. So that
Yeah.
might be another strategy for reducing the
Yeah.
runoff.
Yeah.
Thank you. Thank you,
point.
Alan.
Okay.
I-
Beth, really quickly. We don't want to hold people over here.
Yeah, I just wanted to mention that the FFA, the Future Farmers of America, is a fertile ground, so to speak, for implementing new policies and practices. And since we already have a youth voter registration effort going, maybe we can also attack the Future Farmers of America group with the notion of implementing these pollution reducing measures when they are farmers.
Yeah, that's a great point. And I think there's a lot of different farm groups that would be productive to try to engage with. The farmers who are trying things like this and are really interested in this, they are very innovative. And I've seen a number of talks by them. And they are very proud of how fertile their soil is too. They in their talks, they have, they show the first 10 inches of just beautiful black topsoil, that results from no-till and cover crops. So again,
Alan,
I think
is there
an
organization of those farmers? Are they?
No, my suspicion is no, probably not collectively are they connected together, although maybe possibly through extension agents or that kind of interaction, there might be a way to connect them. I think I'm probably the wrong person to ask about that.
Okay. Anyway, thank you so much for talking to us today.
Thank you for inviting me.
This was a talk. We don't have talks like this very much. And so it was really a new subject kind of for us. So thank you so much. And we really appreciate your coming today.
Well, please feel free to contact me later too. If things come up that you didn't get addressed, just email me. No problems.
Okay. Terrific.
Thank you very much.
Thank you so much.
Yeah.
Thanks a lot.
Bye-bye.
Bye.